So my name is Tom Stickle. I'm the lead solution architect for our partner programs at Amazon. And what we do is we focus on our ISV community. So the ISVs, the SIs, so this is everyone from the platform providers, so the operating system vendors, the Red Hats and the Microsofts of the world, to ERP vendors like SAP and really everyone in between. And so part of what we'll talk about today are running enterprise applications in the environment. I think you guys have seen a lot today about some of these interesting cloud architectures, and we'll talk about how do you run more traditional application workloads in the environment. So let's just jump in. Grab the clicker here. All right, so why would I want to run an enterprise application in the cloud? And hopefully you got some of this out of the earlier sessions today. But I think one of the compelling reasons is this whole idea of turning procurement into provisioning. So the NASA JPL folks are awesome at this. And at the highest level there, I think they recognize that this is a really interesting attribute of the cloud. One of the things that you can do with the cloud is that you have an idea, you can go and build it, you provision it, and you try it out. And in the traditional world, that process looks a lot different, right? It's about acquiring hardware, waiting 6 weeks for it to get installed and get updated, then install your applications and get running. And so it's a very different experience in this idea of turning procurement into provisioning. So the capital expenditure, run for as little or as much time as you need to run for, and then you only pay for what you use. We pre-configure machine images from all of these enterprise vendors that we're going to be talking about today. So it's just very easy. I mean, some of the stuff takes 6 hours to install and configure in a native environment. We have these machine images that are pre-configured for the environment. It's a secure environment. Hopefully you learned a bit about that today in the security presentation as well, in terms of the operating environment and how we divide things up. And it enables global reach. So AWS, I think you really have to look at the cloud and not just think about where we are today, but where we're going to be a year from now or 10 years from now. And if you look at the global expansion that we have, I think it's really compelling for a lot of the agencies that have a global footprint. So if I'm a federal customer, how do I get started in the environment? So if you haven't looked at AWS in detail, the typical way you get started is like ordering a book from Amazon.com. You register for the site, you enter a credit card number, and you provision servers. And that's essentially the idea. If you're a federal customer, you can purchase directly with a purchase card at aws.amazon.com, just like commercial sector customers can. A couple of other options, though. So we partnered up with Aptus and URS, who's our partner. They're here and sponsoring the event as well, to get listed under their GSA IT70 schedule. And so that's one way to purchase. The GSA is Infrastructure as a Service BPA, so this is apps.gov. And so that's another option that you have in terms of a purchasing vehicle. So I think fedcloud.com is the Aptus website where you can look at this. As a prime, so if you procure AWS services as a prime contractor in a pre-competed contract, and the last option is direct purchase order. So those are the ways that you can procure services today, and we have lots of customers who are doing so. And once you do that, once you have this process provisioned, how do you get started? So it's actually very simple. You'll see that when we want to provision machines in the environment, we get a screen like this and say we want to start a Windows server. You basically have a menu of machine images that you can choose from. And so here we can choose a Microsoft Windows server. I can select it. I can specify which region of the Amazon regions I want to run it in. And then I RDP into it once it's started up. So for 15 minutes or so, the server starts up and I have access to it. And I RDP into it, and you have your desktop, and you can start working with it. So customers take that desktop, you can install the software that you'd like on it. You can create a new machine image from it when you have it the way you like it, and you can save that off for other folks to use. And so it's very simple to get started and get running with. We're basically in the compute side of AWS offering compute infrastructure as a set of virtual machines. We have lots of options for getting started, right? So we have most of the enterprise vendors, and I'll show you a sampling of them, have these options for machine images that run. And so Red Hat on AWS is another option. And you'll see, in terms of the pricing for these, what we do with the operating systems is we have a core price that we sell our services at. So what we do is we have pinned infrastructure, so pinned CPU and memory, and we offer various instance types that you can buy. And so the smallest version we'll price at 8.5 cents an hour for the standard size small server instance. And what we do is the Microsoft instances are 12 cents an hour, and the Red Hat instances I think are 14 cents an hour. Don't quote me on that. It's all listed on our website and the pricing. But that's the general idea, is that it's an hourly fee, and this is how you get started. So if you want to take a look at Windows Server 2008 R2 in the environment, you can spin it up and start playing with it. Same with RHEL. Same with SUSE. So lots of options. So the first key in building a platform like ours is really getting a rich ecosystem of partners. And so this is something we focused a whole lot of time on. And so you can see in the just a sampling of the software vendor partners that we have. And what we've done is we've worked out licensing with these partners for the environment. We continue to do this. It's an ongoing process, right? But all of these software vendors and platform providers have different licensing options for the software that they're providing. And we'll talk through some of it. But the first step in getting started with enterprise applications is to talk to your existing software partners, your platform providers, and get the licensing options for working in the cloud. And so we'll look at a few of these. So one is Microsoft. And actually, we've done a ton with Microsoft this year, and which is a little bit surprising, because at some level we compete with Microsoft in the cloud space, but in other levels we're just a channel for providing software and their platform for customers. And so I think from our perspective, we're really interested in seeing a rich, vibrant community for Microsoft customers in the AWS environment. And we've had a lot of customers come over to the environment who are running collaboration applications with SharePoint. I'll highlight a few of these. And so in terms of licensing for the infrastructure, we have operating system licensing, and we have this idea of what's called Microsoft License Mobility. So this idea of being able to take your existing enterprise agreement with software assurance and bring your own license to the cloud. And so this is something that we've worked out for Microsoft Exchange Server, SharePoint, SQL Server, so most of the enterprise products that are available there. With Oracle, it's actually a similar option that we have. So all of the products are certified, or basically all the products that Oracle certifies on OVM are available in our environment as well. And so this covers things like WebLogic Server, it covers Oracle PeopleSoft, Oracle applications. It's really the whole gamut, Oracle DB. And so all of these are available, and we'll walk through the process of getting started with Oracle in the environment, but it's essentially a bring your own license option as well. And so this is something that we've worked hard on for the past few years. IBM as well. I actually don't have an IBM slide. I'm a little red-faced about that. I should have an IBM slide as well. We've worked out licensing with IBM, very much a bring your own license model as well. And so we're agnostic. We want support for all of these platform vendors in the environment. So the services that we have to support enterprise applications are really these four foundational services. So EC2, what we call elastic block storage, which is really a NAS storage mechanism, persistent storage. Amazon Virtual Private Cloud, which is really virtual networking for the cloud. And then the Simple Storage Service, so Amazon S3. And those are the four real components of building an enterprise application in the environment. We have lots of other services that can be added to augment that, but they're really four services that will help you get started. So if we look at the cloud overall and what we're providing, what we're providing is commodities servers at scale. So what we do is we run at arbitrary scale. We have this idea of what we call a region, which is really a concept of a jurisdictional boundary. We've talked about some of that in the security presentations. The idea is if you put data in the region, it's going to stay in the region. It's not going to leak to other regions. You can proactively move data from one region to another, but it's not something that we'll do. And what we do is we give customers the ability to run applications across what are really data centers. So it's the idea of availability zones. So the idea of availability zones is really a fault separation concept. It's just a simple idea that we have a whole collection of data centers, and what we can do is, by virtue of the scale we're running at, we can have different power providers going into each set of data centers. And so what we can do is say if you create availability zone A and availability zone B, if you put your applications in each, they'll have different power diversity, so a different power provider for each. They're on different floodplains typically. They have geographic separation requirements, network diversity. So those are all the things that we put into in terms of the availability zones and the separation. And so the way that a customer can build an application is to layer their application components across these availability zones for additional availability. And we have services that layer on top. And so Elastic Load Balancer, not necessarily an enterprise service we'll talk about here, but it's an example of a service that runs at scale. And so the ELB, what's special about the Elastic Load Balancer is you can create a load balancer and you can point it at a web application, for example, running across availability zones. And what's interesting about it is that the ELB you can set up to run for 2 app servers, or you can set it up to run with 1,000 app servers behind it. It's dynamic. It'll actually expand and contract based on the demand and based on the instances behind it. So it's actually a dynamic service that lives there that we manage, and it's very easy for customers to get started with. And Elastic Cache, there are a few of these that are just the idea of why have to manage all of those load balancers in the infrastructure when it can just be automatic. It's like pushing a button and we can get them going. And so that's another piece of the services that we're offering. You'll see the services we offer at scale are really smart software running across commodity hardware, and this is the general idea of services in general. So let's look at some examples. So this is kind of interesting cloud examples, and we'll kind of start here, and then we'll kind of walk through more traditional applications running here. So Esri is an important partner of ours. We've been working with those folks for a couple of years now. And one of the scenarios that's really common in the geospatial community in particular is this idea of what they call cache cooking. The idea that we have imagery, and we have layered imagery, but ArcGIS server is really smart in the fact that it can take that imagery and break it up into small tiles, and it can create layered tiles that represent different scales on a map. And then you can take that and you can present it out to customers. And so, the option here is we can store S3 imagery in S3. We can pull it out of ArcGIS server, and we can break it in this process called cache cooking. And you'll see we've got one of the bigger server instances, so 96 cents an hour. And we run that for 16 hours, and it costs $15 to run. Well, this scenario is interesting because if we take the same scenario, but now we have 8 ArcGIS servers, and we run it for 2 hours, the cost is the same. It's $15.36 an hour, or $15.36 for the job, and we just processed it in 2 hours. It would be 16 times 1 hour, except I couldn't fit 16 servers on my deck, so it's 8 for 2 hours. $15.36. So that's the general idea, is that you can get things done in a quicker way using this kind of approach as well. Now we have some other scenarios, a bit more sophisticated, where we've actually done some work on doing this at scale. And so what kind of scale? Well, we processed about 360 terabytes this year through a process that we developed that looks something like this, where we have S3 buckets for the inbound data. Now, some of you are probably asking, how do you get 360 terabytes of data to the cloud to start with, right? And so that's a great question, and I'm going to give you the answer. It's not as sophisticated as you might think. So one of the ways that we do this, if we take the data, we put it on a USB drive. We have a process called AWS Import, and they essentially ship us the data, and we plug it in at the data center, and we put it in the S3 bucket. And this works really well, but it's not quite where we'd like to be in 5 years from now, but it's certainly a good start for getting the data there and seeding it. And so we've done this with very large data sets. And so in this example, we have inbound data that goes to a distributed file system, and then a set of ArcGIS image servers that go and process it, put the data back, and then they can ship that data back to their customers. Okay, so one other scenario that we've used here is this idea of dynamic imagery. And again, this is a perfect scenario for the cloud. I think analytics, this geospatial scenario are tremendous in terms of the mapping to the cloud. In this case, we have dynamic ArcGIS servers that run. And so this is the idea that a customer wants to see a dynamic map. And so they'll come into the set of servers that are auto-scaled. So they're set so that there are 2 minimum servers, 10 maximum servers, and they'll just automatically scale out based on the number of requests coming in. And what we'll do is we'll serve the imagery out of S3, and so it comes here. Now S3, we want to improve the latency. We want better performance. So one of the things we can do is take data from, say, the cities as opposed to the oceans, and we'll cache it. So we'll put it in elastic cache so that the next request coming into the same big city will go through the cache as opposed to going up to S3. And that's another scenario. So these are all cloudy scenarios that we have in the geospatial space, which is very interesting. So these types of applications have really been kind of our traditional sweet spot, right? So this idea of deploying them on EC2, and the EC2 network looks like this. It's basically a flat IP space, and I know it's an eye chart for the numbers there, but these are all independent IPs, big flat IP space, and few availability zones. And the way that this works is that we have an application running. We'll basically deploy it around, so we have algorithms that run to figure out where the deployment will happen. But we use this concept of what we call security groups to lock application components together. And so when an application starts up, the web tier might be down there in the green, and the web tier will be able to accept traffic from the whole world. Everyone coming in on port 80. And then the application server tier might be behind that. It'll only accept traffic from the web tier. And then the database tier, or the data tier behind that, will be locked down so it can only accept traffic from the tier behind it. And so that's kind of how we did things traditionally in the network. So the question is, how do we handle more traditional applications? So deploying SharePoint on AWS is a great example. So SharePoint, SQL Server, Forefront, System Center, how do we get those running up in the environment? And the answer is we can get it running. I think for some of the folks in this room who've done it, because there are a few of you who've done it, it can be a bit challenging because it's really a different way of doing things. This idea of a dynamic addressing, things like Active Directory, they like to know where all of the application components are, and the application components like to know where Active Directory is. And our environment's very dynamic and very elastic. That's not always so easy. And so one of the things that we've really focused on over the past, say, 2.5 years is really developing the environment so that we can make it much more familiar and much more appealing to customers who are used to doing things in a traditional environment. And so, for example, with our networking capability, Virtual Private Cloud, one of the capabilities we have here is this ability to define routes and have what we call public subnets and private subnets, and really the idea is it's very traditional. It's like having a DMZ in a traditional web application. So one of the things you can do is have static addressing for all of the assets that are in the behind in the private subnet. You can assign those addresses from your they're assigned from our IP block, so our 10 network, and you can either have them DHCP'd or you can actually assign them there. So it's a very traditional, static way of building things out. And then on the front end, we can put, in this case, Forefront TMG server, an IDS system that just goes and looks at the traffic coming through, does some packet inspection for collecting some audit data for the traffic coming in, and then forwarding that data back into the back-end infrastructure. And so we think this architecture is actually perfect for taking traditional applications and running them in the environment. And so an example of this is Oracle E-Business Suite. And so we have some deployments now where we have Oracle E-Business Suite running in VPC, and VPC is a very natural place for this. But Virtual Private Cloud has several connectivity options. And actually, if I just back up here, you'll see I mentioned internet, right? So that's the kind of the traditional way of getting in. But there are other connectivity options, and there'll continue to be advances in the connectivity options that we have. But you can also have IPsec tunnels to connect your data center with ours, and so that everything here just looks like an extension of your own data center network. And so this is perfect for internal-facing applications. And then we have a capability we call Direct Connect, which actually allows fiber right to our point of presence. So 1 gig fiber or 10 gig fiber, very much targeted at telcos who can break that up and resell it, so customers can order, a connection and connect up into the cloud. But this is a very important technology. It really shows the direction that we're going in. And so we have lots of connectivity options, lots of ways to get into the cloud. So Oracle running here. In this case, they have Oracle Data Guard running to get replication of the data that's here. And so here's another example. And this is not from the federal space, but I wanted to show it as an example because we have a few of these customers. It's pretty early on the work that we've been doing with SAP in particular. And so we have a solution architect on our team who works on my team who works full-time at SAP's headquarters in Waldorf, Germany. And we've been working with SAP for a little over a year and a half now, understanding the performance characteristics of SAP on our environment, and working out to make sure that we can support SAP in the environment, and we have a path for customers who want to run SAP in the cloud. And so here's an example for Lionsgate, the movie studio in California. And one of the things that they've done is move their whole dev environment. And consider this is an enterprise application. It's not just a single application HR system that they moved up. It's a dev environment representing their entire enterprise application up into the cloud. And so they're running the dev environment there. They're moving what they call the landscape, their QA landscape, up to the cloud as the next step. And so we're finishing that work up. And so they're really paving the way. And this is the SAP ECC, so the full ERP system. It's a business warehouse. It's also the CRM system. So it's a good representation of the environments there. And so we're continuing to work with these guys. And it's only a matter of time before they start running production applications here. And so you sort of see the trend. It's very early on in this space, but I think there's a great opportunity if you're an SAP customer to build a new landscape in the environment. It's very easy to set up, very easy to try new technologies out, and when you're done with it, you can shut off the whole environment. Okay, so I just wanted to point at a reference architecture. So this is an architecture that we've used on the database side of the world that's worked out really well in our environment for building enterprise applications. And so in this case, this is a SharePoint environment. Well, it's meant to mirror a SharePoint environment, so SQL Server on the back end. The idea here is very much that we'll break up the tiers of the application. So a traditional 3-tiered application would have the external interface, so the web server, divided up between availability zones, so running active-active redundancy with a load balancer that balances the traffic between the two. App servers, again, broken up. Now, the key piece here, though, is that both app servers here are talking to the same primary database. And in this case, an example, SQL Server primary database. And what happens is there's synchronous replication going on in the form of what Microsoft calls SQL Server mirroring. And so this is mirroring to a secondary server. And the idea is, and there's a third server for N+1 redundancy that's there, observing the transactions. If there's a failover event, the idea is just that the application will fail over, and these two app servers will then start talking to the SQL Server on this side. Now, if you're using the native SQL Server drivers, that happens automatically. You may have to put a script there to detect the failover event and make that happen. But that's how customers have been doing this in the environment. And the same scenario works beautifully with Oracle and Oracle Data Guard. And so that's the other side of this. And I know Reed had talked about RDS and some of the options you have there. You do have the option to use RDS, and what we've done is simplified some of this for MySQL deployments. But in the enterprise where you have DBAs and you have large-scale database systems, this is the mechanism that we've been using successfully in a lot of the early applications. Let's see, what else can I tell you about this? So, I think those are the relevant points, is synchronous replication of the environment. And by the way, this is not any kind of rocket science. It's active-active redundancy. This works really well in traditional data centers as well. It's really just good practice to have some redundancy in HA and DR built into the environment. Now you can add additional levels of protection as well. In the example, you can use in this example we can use asynchronous replication. So what SQL Server would call log shipping, to then take the data from the secondary device and ship it off to either another availability zone or even out to another region. And in the Oracle side, we are doing this with Data Guard to another region in a few of the applications that we've been working with. So again, these are all ways that you can get additional high availability, additional disaster recovery capabilities. The key piece for this, and we were just talking about this a bit earlier with some of the folks here, is it really depends on your recovery time objectives, recovery point objectives, how you design the back end of these systems. I think the important thing to know is that it's very much about what the recovery time looks like. If you're okay with taking 2 hours to recover from a disaster event, then it's okay to ship data and trickle data overnight, logs, transaction logs from one region to another. And if something really bad happens, you just start up the whole environment in another region, and that might take an hour to get everything in sync or up and running, and that might be sufficient. But if you're running an application where you have very low RTO, RPO requirements, then these types of designs tend to work pretty well. Okay. The other thing, I actually have this little animation at the end. I just want to, you notice that we can log ship the data over to another region, and we can build machine images that represent the application components in that region, but we don't have to run them. And so that's an important piece, is that you don't have to, we don't necessarily have to pay for the machine images to run the web tier and the application server here. We can just have them there in case an emergency happens and then spin them up and take advantage of them in that data. Okay, so I want to shift focus over a bit to the security side and how we secure these applications now that we have them up and running in the environment. And I think CJ earlier on probably talked about this. He loves to talk about this. When we get involved in enterprise applications, the first thing I always recommend for our teams internally is go talk to the info security team. I mean, it's always worked really well for us. The biggest problem on the info security side is just educating people about what's different about our environment versus running something in your own data center or in a managed hosting provider or something more traditional. It's just a different paradigm because of this idea that customers are taking our building blocks and they're putting them together to make an application, and we control some of those building blocks, but then they're taking control of the application. The prime contractor or the agency is taking control of the final product. And so there is a shared responsibility model. And this is the big difference in the environment. And so we have responsibilities for things that are in our control. So the facilities, everything from the concrete up to the operating systems that are running in the environment, the virtual infrastructure, the logical separation that we have in the environment, all of the virtual machines and the virtual infrastructure. But customers are still responsible. When I say customers, I say this loosely. It can be a partner, whoever's hosting the application here, whether it be an agency or the contractor, is responsible for patching. They're responsible for configuring our security groups correctly, responsible for making sure that they have antivirus installed, and so a lot of the traditional security practices that happen there. And so that's an important differentiation. And so one of the things that we've spent a lot of time working on is building an ecosystem of partners that can help with that piece of the security puzzle. And so I think you'll see we have a pretty rich collection of partners that we've developed over the last few years to help with security needs. And a lot of them are the same partners that you would work with internally. And so I just want to give you an example of one that we've been working with for quite some time now. So this is Trend Micro. And Trend Micro has security solutions that really range all different areas, but they have one in particular called Deep Security. And Deep Security is a system that has modules for malware, for IDS, for audit, for firewalling that you can plug in, and they run on individual server instances, but they can be managed centrally. And so this is a solution that we've seen deployed in the environment very successfully. They have another solution too, and another area for those of you who are really interested in the data protection side of things called Secure Cloud. And so in that solution, what the focus area is on is key management. So encryption, very simple thing to do. Key management, very difficult thing to do. And so one of the challenges in the cloud world is that, on-premise world, you can plug a hardware security module, an HSM, into a server. The keys are created there, they live there. But when you run things in a virtual world, we don't have this idea of an HSM. And so getting keys delivered securely is a challenge. And so these guys, we've spent a lot of time working on security protocols for secure delivery of keys into the environment. And there are actually two solutions that I'm very bullish on this side. So this from Trend Micro called Secure Cloud, and the other from SafeNet, which is called Protect V. We've done a lot of work with both teams, and we're really happy with the progress for both of them in that space. I think we'll see a lot more. There's a whole ecosystem of startups that are working on cloud security. There's one called Cypher Cloud that's very interesting. There are a bunch of them that have come up. But the key management piece, that there are only a few vendors that do that as a day job anyway, and so we really wanted to work with them to make sure that we have key management and crypto capabilities. Now, those early solutions are very focused on cryptography in terms of encryption of data to media. Not very much in terms of digital signatures, just general crypto, hashing, symmetric algorithms. They're not really geared towards that. But it's a good starting point. We can see a lot of future solutions that are kind of layered on top of that. Another one that's just a great example of what's coming is this one was developed with one of our partners called Core Security. And Core Security has a penetration testing service. What they did is they built a cloud service out of it. And so the idea is that you can create an identity and access management user, what we call an IAM user in the AWS world. And you can give them very limited abilities. You can describe all of the resources in the environment. You give that to Core Security, and then they can enumerate your environment, and you can select the servers that you'd like to run penetration testing on, and it automatically whitelists them with our security team, and then you can run your tests on the environment. So it's a very nice process that developed. I think it's really a roadmap. We want to support a rich ecosystem for this type of testing for lots of customers. And by the way, penetration testing is not for the faint of heart. So we're opening this up to vulnerability scanning as well. Penetration testing will not only find vulnerabilities, but it'll exploit them. So it's not for everyone, but this is a very good service for getting started. So I just wanted to show a picture of the partner ecosystem on the security side. And I don't have the big platform providers listed in here. I really have the specialized security partners, but I think it's much deeper than this when you look at the security solutions available from the platform providers, Microsoft, Oracle, IBM. But just to give you a snapshot of the folks that we've been working with, and I had mentioned SafeNet, which we've done a lot with. Layer 7, who's a sponsor here, done a great job in terms of threat protection, trust management, and another great partner in terms of threat protection capabilities for the environment. And these companies have machine images and the ability to work inside our environment to help protect assets there. So we have some on the identity side, Okta, Ping Identity, Simplified. There are a bunch there. Splunk has been a great partner of ours. If anybody here's worked with Splunk before, it's just great for log aggregation and indexing, and it's just actually a perfect fit for the cloud. And so we've done a lot with these guys as well. So that's just a general look at what we have. So I just want to give you a few reference points for where you can find out more about some of the things we talked about. So in terms of architecture, one of the places that we have is on aws.amazon.com. We have this architecture page, and it has a set of reference architectures, covers some of the things we talked about. How do you create a web application architecture? And it's a good reference for how you can build it in a highly available way. So yeah, actually there are a few examples here. Web hosting, leveraging storage options, just cloud architecture, some of our learnings from the Amazon.com experience and building out some of that infrastructure at scale, and then some of the security as well. The page for everything security is aws.amazon.com/security. And there are a couple of things interesting here. Firstly, if you want to do vulnerability scanning or security assessments, penetration testing, we have a process for doing that. It's from this site here where you can link in, and you basically register your account, and you can whitelist instances that you want to run penetration testing on. And so I would highly recommend doing that. It's required if you want to do pen testing or vulnerability scanning in the environment. We frown upon port scanning without knowing about it up front. But there's a white paper here that's actually very useful as well. And so I think there's some great resources that you can take a look at. And the last one is aws.amazon.com/federal. And so this has all the information on the buying piece that I had talked about, how you can get in touch with us, how you can procure software for the federal space, and just an overview in that sense. And I think one other thing I just wanted to touch on quickly, and we'll take questions. I think in terms of where we're going, in terms of the partner ecosystem and enterprise applications, I think we're not quite there yet. Early days. I think one of the things that's really interesting is next year is definitely the year of the appliance vendors. We are very, very focused on getting appliance vendors. Citrix, F5, all of these guys. We want them all running in the environment. We want to have a really rich ecosystem for that set of partners. And so I think that's something that we'll be working on diligently into next year to help build out that whole set of partners as well. So I'll stop there and see if there are any questions.